you can start. So yeah.
Yep.
So today, so we will go through ERC20 token. Before that, there are any questions or comments we should look into? Otherwise, we will start with some example on the ERC20 token. Okay, but you can also put comments in the chat and questions or comments. Yeah, you can start.
Okay, I will do that. I'm just going to share my screen. Can you see my screen?
Yep.
Okay, great. So yes, so hi everyone, welcome back. Now today I'll be talking about ERC20 tokens and what they're about. So we will have the following outline. It follows the same or similar outline that we had before, where we go through some theory and then we actually try to create some of the or implement some of the theory into practice in the form of demos. So we're going to start talking about ERC20 tokens and what they are. And then we're going to have a demo where we create our own ERC20 token. And we'll show you how to do that. And then we'll talk about what a decentralized autonomous organization is. It's called DAO. And we're going to discuss briefly about that. And then afterwards, we will have another demo where we will create a so-called market vendor for our token. So the token that we create here, we're going to actually build upon it and try to create an autonomous smart contract that acts as a market vendor. So that is the plan for today, and we'll see how much we can cover today. So if we start with ERC20 token, what is a token? So let's start with what a token is. So Ethereum, Ether itself is a token. So it is just a digital asset on the blockchain. Now that is a bit vague of a definition and it captures a lot, but if we're asking what an ERC20 token is, then it is essentially a ledger. And what I mean by that is it is essentially a smart contract that you have. You have one smart contract per token, you have one smart contract that acts as the infrastructure for the whole token, right? So let's say we have a token called Maker, then there is one smart contract that essentially controls it. And so to explain a bit more, it might sound a bit confusing at first, but we'll take examples and hopefully we'll get clear. But it is a ledger, which means that unlike Ethereum, when you send one, unlike Ethereum, wait, I'll just go back again. So when we say it's a ledger, what we mean is that there is a balance sheet. So that smart contract keeps track of who owns how many tokens, right? So you actually don't own any tokens in your address, but there is a smart contract that acts as a ledger. So let's say you have 10 tokens and we want to verify that. What we have to do is go to the smart contract associated with the ERC20 token, and there it will have a data structure in which it will say this, Siddharth, my address, and then 10 tokens. Again, we'll go through more of it, and then it will become clearer, hopefully, what we mean by it. So ERC20 simply means Ethereum request for comment 20, and it is just a standard for developing tokens on Ethereum. So a lot of people wanted to develop additional tokens beyond Ether, and to do so, everyone started developing their own tokens. Now, the issue was that there was no one standard for doing so. And that meant that many different token implementations were created, and that wasn't the nicest way to actually handle it, because as the ecosystem grew, the number of uniquely made tokens grew as well, and there was no standard. And people sought to have a standard to make things easier. And so in 2015, they started working on it, and in 2017, it was implemented and adopted by the Ethereum community. So since 2017, we've had ERC20 tokens. And as I said previously, it forms an attempt to standardize tokens on Ethereum, so that if you want to create a token, you can actually go for it. All you have to do is follow a standard. And we'll quickly talk about what a standard is. Now, I will repeat this over and over again. When we talk about ERC20 tokens, what we're talking about is actually one smart contract that is behind these tokens. One smart contract that actually keeps track of who has what. You can think of it as like a bank account, right? So you have in your bank account, you have an account number, which can be your address, and you'll have some money in your bank account, which is a value. it operates in a similar way. And we're actually going to implement our own. But before we do that, let's talk a bit more about what the ERC20 standard means.
Yeah, maybe let me complement here a bit.
Yeah.
So, in a sense, it is like creating your own currency. Let us say that, right? Because even if you look into the fiat currencies, they are controlled by some governments, and there is an entity controlling the currency, right? In that similar sense, even ERC tokens is like a small currency, which is maintained by the smart contract, or you can say who owns the smart contract, he's the one who manages. And what it has is some kind of the keeping track of who owns how many tokens, and that is basically what it means. Go ahead, Siddharth.
Yeah, so yes, and hopefully it will become more clear the more examples we use it. But if we start with what the ERC20 standard is, so the standard is for a smart contract. If you want to create a token that's ERC20, then you need to follow the following standards. So there are minimum requirements of 9, some of which are optional, but there are 9 of the standard API. What do I mean by standard API? I mean functions and variables that have to be in the smart contract that you're building for the token smart contract. So the first one is name. And I have a maker as a token here. It's actually a very popular token in Ethereum. So if we look at it, the name is what it's called here, maker. And then the smart contract needs to have a symbol so it can be identified easier. In this case, the symbol is MKR, shorthand for maker. It's not the logo, it's this one, the shorthand. And then we need to know how many decimals the token can have. As in, if we have 100 tokens, can I actually send you half a token, in which case we have a decimal point of 1? Can I send you 1/100th of a token, in which case we have decimal places 2? Or do you want to do it as we do for Ethereum, which is close to 10 to the 18? 10 to the 18. Yeah, so it'll be like 18 or 17 decimal places. So that's what this dictates. And then we also need to have in the smart contract, we also need to have what is called the total supply. So what is the total supply of all the tokens? Is it 100? Is it 1,000? Is it 10? That's what we define here as well. And then what we need is a function called balance of, which, as we have it here, it takes an address of an account, right? So if it's me, I'll have an address. I have my own account, which will be the address, and it's a function that you can call on the smart contract. So here we have a smart contract. We need to be able to have a function called balance of in the smart contract that tells you how many tokens you have. And remember, last time I said ERC token is nothing but a smart contract that is a ledger. And this is how it would look overall. So this would be the ERC20 token. And let's say that in the start, let's say Bob has 15 tokens and Jane has 10. And now if we want to know how many does Jane have, all Bob has to do is call the function on the smart contract called balance of, and he passes Jane, and then he gets 10 in return. Now, one thing I want to make clear is that I use the words Bob and Jane and things like that, but they're a shorthand for an address. So always remember, it's always an address. So when we're talking about a person, we're actually talking about the address of the account that they have. Just something to remember. But again, just to reiterate, this is how the smart contract is. It is a ledger, which means it stores the address. So Bob will be an address, and it will store the number of tokens it has, as well as with Jane. And the important thing to note is that Bob can ask anyone's address. It can ask anyone's, it can send anyone's address here, since Bob is the one asking to know how much does Jane have, and he will get that response back. And that is important to know as well, in that all it requires is for us to send an address, and it will tell us exactly how many tokens that person owns. So there is no privacy in this part. So now we've covered 5 of the basic ones, and now we will go towards looking at the 4 other functionalities we need. And there will all be functions like the balance of, but they serve different purposes. So we have a function called transfer. So again, this is a function that has to be implemented on the smart contract of the token, which allows one person to transfer funds from one account to the other. Now, if we go back, that is essentially, let's say Bob transfers 5 of the tokens to Jane, then all that's changing is that on the smart contract, Bob's balance will go down and Jane's balance will go up. Okay, and we'll actually see an example of transfer as well. And then we have something called approve, which is a more unique one. Again, I will actually like to explain these with examples, so I'm just gonna go over, and there's something called allowance. And then finally, there's something called transfer from, which is very different from the transfer one. And we'll see how they're different. So let's begin with transfer. So, okay, I've set some things up. So let's look at the scenario before we do anything. Let's say before the transfer, Bob has 100 tokens and Jane has 0 tokens, right? And then Bob decides to transfer some to Jane. What does he use? He has to use the transfer function, which requires Bob to be the one to send it to the smart contract. But let's just look at the types of the arguments in the transfer function. First is the address for whom the tokens are sent to. So in this case, if Bob is sending to Jane, we have to have Jane's address here. And then we're going to have how many tokens he wants to transfer. So before transfer, we have Bob had 100, Jane has 0. So now Bob initiates a transfer to the smart contract. And again, it's like what we described before for the balance of, in that it's the smart contract that will have a function called transfer that Bob can call. So Bob calls transfer, and all the smart contract does is adjust the balances. So remember, this is important. Bob is not sending anything directly to Jane. There is no Bob to Jane. If Bob were sending either, then he would be sending to Jane directly, but he's not. In ERC20 tokens, the transfer is simply a function on the smart contract. And all it does is change the balance overall that the smart contract keeps track of, right? So after the transfer, what happens? Bob will have 90 tokens and Jane will have 10 tokens. Now, remember the balance of function we introduced before? Now, Jane can actually ask the smart contract again. She can actually send her own address, and she says balance of the address of Jane. And because this is how the ledger is looking, she will get 10 back. She could have also asked for the balance of Bob, in which case she will have gotten 90 back, just as information. And we can move forward.
Yeah. Just 1 second.
Yes.
So I want to comment on this. Yes, I don't know how many of you are aware of digital shares nowadays. If you buy shares, for example, from a company called Reliance or some other company, and you can buy shares and you can sell shares. What happens in the background scenes is if you sell your share in the Reliance, and then let us say that someone has bought, the details of the ownership of the shares will be adjusted at the Reliance company, right? So they note it down that, okay, the share number, the shares X number of shares with serial number so and so have been now transferred from this person to the other person. It's also the similar, in a similar case, here we have basically the smart contracts contain a data structure, which actually keeps track of who owns how many tokens. That is what is happening here.
Yes.
Go ahead.
Yes, and I just want to say, for example, if I just want to reiterate that these tokens are actually not at the address of the person, right? And the way I want to reiterate that is this is the only place where we actually have the balance of the tokens. So let's say we go in, let's say by some hack, we go in and we just change this 10 to 0. What happens is that Jane now has no tokens. If we do the same to Bob, Bob now has no tokens. So this is the source of truth. So the smart contract for the token with the balance is the only source of truth. So that's a bit important to remember. Yeah. Then let's look at some more complicated ones. And we're gonna look at approve and allowance that I really didn't discuss before. So before in transfer, what we saw was the tokens were actually moved from one account to the other, right? In the ledger. But there is also another function called approve, which someone like Bob makes. And all it does is that it doesn't actually transfer the token. So let's say Bob says approve. Let's look at the signature of the function. You have to send the address of someone called the spender, and then you have to send how much they can spend. Now, if Bob, before we click approve, let's say Bob has 100 tokens, and Jane has only 0 tokens, Bob can approve Jane for 20. What that means is Bob has allowed Jane to use 20 of her tokens. And we'll see how Jane can actually make use of that. But the important thing to note is that when you say approve, that the tokens are not transferred to Jane. And that is reflected by the fact that Bob still has 100 of his tokens and Jane still has 0. Right? So it started at 100 tokens for Bob and 0 tokens for Jane. And even after approve, what happens? Bob still has 100 tokens, Jane has 0 tokens. What that means is if Jane then goes to the smart contract and says, how many tokens do I own? It will return 0 given by the red number, because the approval isn't actually a transfer. All it says is that Jane can actually transfer funds from Bob, and we'll see later how that is. Now,
in a sense, it is like an authority which is Bob is delegating to Jane. So it's like saying that, okay, for these 20 tokens, I delegate the authority to Jane so that the Jane can send or sign on behalf of the Bob. And yeah, go ahead, Siddharth. Yes.
Yes, yeah, exactly. And I think this will become more clear when we look at transfer from function. That will come later. Now, but let's look at allowance. So we know that Jane has 0 tokens, right? But the allowance function is something where you send in 2 addresses. In this one, we're basically asking how many tokens of Bob's can Jane spend? And it will give you 20, because that is related to the approve function here. So again, Jane doesn't have any of the tokens, but she can spend it at some point using some function, which we'll get to. And we'll see why this is very useful later on. So if we move forward, we'll come to the actual function where we can use it. So let's first look at the signature of the function. So it has an address sender. So that's the person who has the tokens. And it has a recipient. That's the person who will end up getting the tokens. And then it has the amount of tokens that are being transferred. So how is this different from transfer? Well, let's just look at that. In transfer, all that happened was Bob was transferring to Jane, and that's all he says. So Bob is the one initiating this call to the smart contract, and he says, well, transfer to Jane. But here we have 2 addresses. And why is that? Well, let's look at what happens before we call it. So before we call transfer from, let's say Bob has 100 tokens, Jane has 0 tokens. This is the same example from before. Jane has 0 tokens. We have it here as well. And then let's say we introduce a new person called Dave, and he has 0 tokens as well. Now Jane, because she's been given permission, will call the transfer from token and says transfer 10 tokens from Bob to Dave. Okay? And in this ledger, what happens is Bob has now lost 10 tokens. Dave has gained 10 tokens. Now let's look at what happens after the state, after the function has been called. Bob now has 90 tokens. Jane has 0 tokens, just like how it started, because she never owned the tokens. But now Dave has 10 tokens, right? So essentially what has happened is Bob has transferred to Dave, but through Jane, and that is important. So this one will only work if Jane is allowed to spend some coins from Bob. And how is Jane allowed to spend? Because Bob approved Jane to spend 20. And that's very important. And we'll actually see more of the example. So in the first situation, she only spends 10. Remember, she's allowed to spend more than 10. And in the second one, let's say now we're in this position, and after this has been executed, we have this account in the ledger, and now Jane initiates another one. And here we have a new one called Ankit, which is misspelled. So here we have the situation after the first transfer from function has been done. So we have Bob with 90 tokens because he gave 10 tokens to Dave through Jane. We have Jane with 0 tokens because she doesn't actually own the tokens. And we have Dave who just got 10 tokens in the last transfer. Then we have Ankit with 0 tokens. And what Jane does is Jane, because she's still allowed to move 10 more tokens, then decides to move 10 tokens from Bob to Ankit, a total of 10 tokens. What happens in the ledger? Well, Bob reduces his total account share of the tokens by -10. He loses 10 tokens, and Ankit gains 10 tokens. So what is the end result? Bob now only has 80 tokens. He gave 10 to Ankit, 10 to Dave. Jane only has 0 tokens because, again, she never owned them in the first place. Now Dave has 10 tokens from before, and now Ankit also has 10 tokens. And that is the interesting thing to note. It looks very confusing. I can understand that it is a bit confusing, but hopefully when we see the code, it will become more clear. But essentially, what this represents, this transfer from function, is it allows delegation. It allows Bob, who trusts Jane, to make decisions for him that include the transfer from function. So Bob is trusting Jane to send it to whomever. Jane could send it to herself as well. All she had to do was say transfer from Bob, Jane, 10, and Jane would have gotten 10, right? So you can think of this middleman, Jane, as a lawyer, right? Let's say you're buying some stock or property or something, and you allow the lawyer to negotiate on your behalf and then sign it. Then that's what Jane is doing. So Bob trusts Jane, and then Jane can then transfer a certain amount of money from Bob, which we have here, 20 in this case, to anyone she likes, including herself. But she transfers to Dave here and then Ankit here. And the way she does it is through the transfer from function. And this will only work for Jane. So let's say Dave instead tried to transfer from Bob to Dave, it wouldn't work. Why? Because Dave has not been approved. The only person who's been approved is Jane. And that's important. So the smart contract keeps an eye on who's the one sending these function calls or who's calling this function. And that's also very important.
Yeah, maybe let me briefly compliment here. So this is more or less, even though it looks a bit complicated in the first sense, but this is more or less like what is happening in the IPOs as well. So for example, in case of IPOs, when a company want to go for public, they want to sell some of the shares to the public. Then what they do is they will go to a securities management company, either a financial institution or a bank or whoever it may be. And then the security manages company, the company will actually launch the IPO on behalf of this company, right? And then when people are compete to buy the shares, and the securities company will handle all this process, and they will look into how many applications they receive for the public shares and things like that. And if there are more people who want to buy the shares, then they will take some lottery or some other kinds of scheme to allocate the shares. And all these things are decided by the security company, not the original company, because the original company, they have delegated powers to hold this IPO to the securities company. So more or less in the similar lines, even the smart contracts have this approve and transfer from functionality, so that in a bigger sense, when they have the coins for the bigger companies and things like that, they can emulate the same kind of behavior in the marketplace as well. Otherwise, it will be very difficult for the company to do everything. So that's why they introduce these intermediaries and this kind of functionality to allow the intermediaries to transfer on behalf of the company. Any questions or comments? And if you don't get it, maybe put a comment or question, then we can discuss it here. Otherwise, we can proceed. Yeah. Go ahead.
Okay, now I will proceed. And hopefully when we actually do the demo, like a lot of times, hopefully it makes more sense, but then we will take questions again after we do the demo. And the demo I'm going to do is from the website called Solidity by Example. It provides a pretty simple ERC20 token infrastructure, and we're just going to use that. So I'm going to walk you through what that is doing. And of course, if you have questions, please put it in the chat. Okay, now let me just first start by opening Ganesh. And then also my Visual Studio Code. Okay, we have our Ganesh here. We'll just keep it running for now. And okay, now can you see my screen?
Yeah. Yep.
Yes. Okay. So here, this
maybe
is
you
going
can
to
increase the font a bit.
Yes. Is this better?
Yeah.
Okay. Just go here. Yeah. So yes, here in this situation, we're creating our own ERC20 token. And we're actually going to look at what it's going to be doing. So first we have something called an interface. But before I get to all that, I just want to show you that this is the contract. And if you can see, it has it has to approve, or it has to implement some of the main functions and variables that the ERC20 standard requires. And what those are actually in the interface. So in Solidity, the interface is similar to other object-oriented programming languages in that but the only difference is here you have to approve them, or you have to implement them. So you don't have to override them. It just gives you the type signature of what they need to be. And in the actual contract, you have to actually put in the body of the function yourself. So again, ERC20 is nothing but a standard. And if you follow that standard, the tokens that you produce or you generate or use are going to be ERC20 tokens. So that is what it is. So if we just quickly look at the interface, let's see what functions we have to do. First is we have to do total supply function, which we talked about before, which means that we need to be able to, anyone should be able to call the contract and see how many tokens there are in total supply. And then we also have the balance of function that takes in that where we pass in an address for the account, and that returns how many tokens it has. And here we're using integers, yeah, we'll just get to that as well. And then we have our transfer function, which is one of the simpler of the functions in terms of transferring money, where we have to pass in a recipient. So let's say I'm calling the transfer function. I have to pass in a recipient, who's the person who's going to receive the tokens, and the amount, which is how many tokens that person receives. Now then we have the allowance, which allows the owner, which allows the spender to spend money from the owner. And we'll see how that works as well. And then we have the approve function, which actually approves people to spend on their behalf. This is a delegation function, which allows where we have to give it a spender and also tells them how much they can actually spend. So let's say if it's Bob calling the function, Bob will call function approve and then says Jane here and 10. And that's what it is. And we'll see examples of this. And then finally, the transfer from function, which we just discussed before, where we have a sender and we have the recipient, where the person calling this is not the sender, but can definitely be the recipient, where Jane can be calling this function and says, send transfer 10 from Bob to Dave. All right, so these are the basic function signatures, and we'll look more in depth to it. So again, in Solidity, we have this interface. So now for this contract that we create, let's call it ERC20, it has to implement all of these functions, otherwise the contract will not compile. So let's look at what actually in there. So the first thing we see is we need to implement these two events as well. So the event is just, we call it transfer, and it tells you where the transfer has gone from, who's the one who started in this case, from whom has the money went. So from, in this case, the value, which can be 10 went from this address, Bob, to Jane. And here, it doesn't matter if it's I don't know, we'll come back to that later. And then we also have an approval, which tells you that the owner, let's say it's Bob has approved Jane to spend 10 or 20 tokens. So these are just events so that people outside of the blockchain can actually, who are following a node, can actually receive these events and see what's going on. And then we have the total supply, which will be all the coins. And then we have a mapping called the balance of. And this is, do you remember when I said the smart contract is nothing but a ledger that keeps track? Well, this is what I mean. Whether someone owns tokens or not is all captured here. A mapping is simply a dictionary. In this case, what is a dictionary? It is the keys of the dictionary are addresses, and they map to integers, which is the number of value. So in that, I have commented out something to give you an example. So in this situation, this is a dictionary where we have an address, which is Bob. And remember, Bob is just a shorthand for an Ethereum address. And that person has 100 tokens. So that's how it is. So if I want to actually have some tokens, if I could access this, All I have to do is increase it, and I'll have my own tokens. So whether someone has tokens or not is entirely dependent on what is inside this dictionary. And that is a bit interesting to understand. Because when I first, if that feels a bit underwhelming, I can understand it. The first time I also learned of how ERC20 tokens work, it seemed a bit too simple, that the whole idea of tokens and stuff is just inside a dictionary somewhere on this one smart contract. But that is how it is.
One thing to complement here is that, of course, we don't have any security and other kinds of things built into this example. But normally, you don't allow anyone to update this dictionary, right? So that means you will have either the person or the address which deployed the contract, and then you will make sure that the proper access rights are delegated when you update this mapping in the smart contract. And one more thing I want to say, that is, we don't need to call our smart contract as ERC20. It could be any name, as long as it inherits from the IERC20 token. So that is the interface. Yeah, you can call any token.
Yes. Yeah. I just want to add that this smart contract actually doesn't allow anyone to just come and modify this. So it already has a security features implemented, and we'll see those security features which are done by default in this as well. So just saying, so if you take this code and deploy it, of course, I think I would not suggest you to do that. I would suggest you to use more up-to-date ones, because since 2017, a lot has changed. But you can actually do that, and this will actually make sure that no one can actually come in and change the balances. So the security systems are in place even for this small one. Just to add, yeah. And then yes, and then so let's then look at something called allowances. Allowance. Now, allowance again is something we talked about before. What it does is, let's look at what it is actually. So it is a dictionary of dictionaries, right? So in this dictionary, it has an address, and that address, the value of that address will point to another dictionary, which is what? Which is another address. Key is address, and then value is the amount of tokens. So let's look at the example again. All this is saying is we can have someone called Bob, that's the key, and that will point to Jane, who points to 20. What does that mean? That means that Bob has now given Jane permission to use 20 tokens. And that's an important thing to understand. And so our whole allowance idea is here. So now you can also have other things. So let's say it was the opposite, where Jane allowed Bob, then it will just say Jane, and then it will have Bob or any other person here, 20. And that's it. So that's how allowances are working. And again, this will make a lot more sense when we look at the actual contracts. So yes, and we also have the name, symbol, and decimals, which are also required. But here I didn't fill them up just to keep things a bit simple. So now let's look at the constructor. So when we create this, I'm actually asking us to pass how many tokens there will be in total supply. So here the total supply is going to be, can be 100, 1,000 or something. And when I'm doing the demo, when we deploy them, we can actually set this ourselves, and we'll see that. And this one is not, it's not a part of the requirement, but all I'm saying is, we'll look at what a min function is. All I'm saying is the message sender is the person who is the one who created this contract. He should get all the tokens. Now, again, I'm only doing this for the sake of simplicity, and we'll see it, how it's beneficial when we're actually doing some experiments and testing this out. So let's look at the transfer function, right? So as I said, let's start from the basics. The transfer function takes in a recipient and takes in an amount. So the recipient can be anyone. And the way the function works is it looks at who the message sender is. So before we look into the function, let's just see, let's say someone calls this function, right? Let's call him Bob. So Bob becomes the message sender, and the recipient becomes Dave or Jane or anyone. The way that the function works is it looks at the balance of the person sending it. So if this is Bob, it will look at the balance of Bob, and then it will adjust the amount by reducing it, because he's the one person transferring out, right? So it would reduce, let's say if this was 10, let's actually write it down. If this was 10, then now this one has been reduced by 10. So the balance of Bob, if it was 100, is now 90. And then the balance of the recipient, which is what we have here, will then be increased by that amount. So if this was 50 before, 50, then it will be 60. 60. And what we do is we emit an event saying that, okay, the person calling the function message sender Bob has transferred to Dave amount of 10. So in this case, I want to just clarify that in this function call, it's very important who's the one calling it, right? So this ensures that if anyone, so using this function, you can't say that, oh, Bob transferred to Jane if you're not Bob yourself, right? That's important to note. So if it was Ankit calling this function, then message sender would be Ankit. So that's already built in. So this is one of the security features that we're talking about, right? It's simple, but it ensures that people can't have access to the balance of. They can only have access to it using these functions. Yes.
And one thing to complement here is remember when we discussed about Solidity and Ethereum infrastructure, we were discussing that there are global variables. For example, message and other kinds of global variables, timestamp and other kinds of things. These are part of the build of the infrastructure. So that's why you will always have the message.sender containing the address of the person who is making call to this function on the smart contract. So that is so nobody can mimic that. So it is part of the infrastructure. So you cannot easily cheat that one. Yeah.
That's a good point. Because the only person who can call this function will be, if Dave is the one calling it, the message of sender will always be Dave. So it can't be that someone like Jane or Ankit can't forge the signature. Why? Because by definition, that's how Ethereum is done, and that's how blockchains are done. So they insure against this. And if you want to go a bit deeper, they insure against this because of the private key. So the only person who can actually send this would be the one who has the private key. Yeah. Yes, and I will continue. And now let's look at a proof. So we talked about approve before. Now let's actually look at what's happening in the code. So let's say we have message.sender. Let's say it's Bob again. And we actually want Bob to approve Jane to spend some of his tokens. So Bob is delegating some authority to Jane. And let's look at what it is. We looked at the function signature before. It has a spender and it has an amount. So let's look at what is happening. So I told you about allowance before. We can just go back up again. It is a dictionary of dictionaries, right? So what allowance is doing, it's looking at Bob. Message.sender is Bob in this case. So it's looking at Bob's dictionary. And once it accesses Bob's dictionary, it puts Jane and says Jane can now spend 20. So this is, if I just write down here what we have here, this is exactly what is happening here. Yes, approve, yeah. All that is happening here is, is this. So Bob, Jane, and if amount is 20, then this is what's happening. So allowances will become this. The dictionary of dictionary data structure becomes this. That's all it is. And then we emit the approval event saying that message.sender Bob has allowed Jane, the spender, for 20. And again, I want to repeat, because we're using message.sender, no one can approve on behalf of Bob. So if Bob is the one calling this function, then he's the only one who can approve. So Ankit or Dave can't come in and say, okay, I'm approving this for Bob. That can't happen. Why? Because message.sender. Yeah. Yes. And then let's look at transfer from. This is the one that's going to be a bit more complicated. Actually, before we do that, let's look at transfer from. This is the last function we're going to look at. And so what we're going to do here is we're going to do a transfer of tokens from Bob to Ankit through Jane. So we're using the same example that we saw on the slides. So message.sender in this time is Jane. And that's important because Jane has been approved. So only Jane can be the sender here. And then the sender, or the sender of the original tokens, owner of the tokens, will be Bob, and the recipient will be Ankit. and the amount can be 20. I'll just write that down here. Yes. So let's look at what's happening. So first, what we do is we actually deduct the amount from the allowance. What is the allowance? This is the allowance where we go into Bob and see who he has allowed. Well, he has allowed Jane, who is message.sender. And so we reduce the allowance of Jane by 20. Why? Because in this case, when she called this function, she has spent 20, right? So this way, you're only restricting her to however money you approve for. And then we have balance of sender, and now we actually do the transfer. And that's, if we look at it, we have balance of, and we have sender, which is Bob here, and we reduce his money by 20. And then we go to the balance of recipient. Who's the recipient? Ankit, and we increase it by 20. So if you notice, this code is exactly the same as a transfer code. They're basically the same, except that the arguments you're sending are different. Yes. And then we emit saying that, okay, Bob has transferred to Ankit 20. Important thing to note here is it doesn't say that this transfer has happened through Jane. And that's important. Why is it important? Well, it's just to know that, so Jane doesn't actually at any point receive any of the tokens. As we saw in the example, Jane never owns those tokens. She just has the approval to spend it or send it. She can, of course, send it to herself. That's another topic. And then I have mint. I put it on underscore because it is just a helper function here to give all the tokens when it's created to the message sender, so Bob. All this is doing is, saying that we're going to give the tokens to whichever address is specified here with the amount. So let's say if we say Jane and then 20, then Jane gets 20. Why? Because we go into balance of, which again, I'll just repeat myself again. Balance of is what controls who owns how many tokens. And it's just a dictionary. We go into the dictionary, we find Jane, and then we increase her balance by this many amounts. By that, Jane has whatever money accounts, whatever many tokens that have been transferred. Yes, and then we say transfer. But again, these are not important because they're not part of the standard. But the way you can think of this is that, well, once you start once you create the smart contract, there has to be some way of giving people these tokens. And what do I mean by giving people tokens? I simply mean is adjusting the dictionaries. That's all it is. And then we have burn, which we're not using, but this is just what I wanted to quickly show you what it means. We're not going to discuss these things because I think we're running a bit out of time, but we can discuss it some other time. But basically, by burn, this is a concept we briefly touched upon last class, where if we say we burn, what are we doing? We're burning some from an account. So let's say Bob. So we reduce his number of tokens like before. So if he had 100, now let's say we reduce it by 20. So now he has only 80 tokens. But importantly, we're also reducing the total supply by 20, which means those 20 tokens are gone. So if before we had 100 tokens, and then we say burn, underscore burn, and let's just say Bob here, and then 20, then yeah, let's say that is done. Then if we look at total supply, it is now 80, which means 20 tokens have been gone, right? And quickly, the reason they might do that is because using something with that is a bit microeconomics, it's called tokenomics. And the idea is simply that if you have demand and supply, there will be a price. But if the demand stays constant, let's say everyone still wants the tokens, but if you reduce supply, the price will go up, right? It's the same thing that happened with oil prices due to Ukraine last year, or due to the Ukraine war. But what happened was the demand has been the same, right? Because everyone still is using petrol and diesel for their cars, but the supply was disrupted, which means there was less supply and same demand. What resulted? What resulted was that the price went up. And that's the same concept here as well. And you can ask, why would someone do that? Well, the people who made these tokens might want to increase their price, because if they have a certain number of tokens and then the price increases, that's better for them, right? They just make more money. Yes, but again, we're not using this function in this smart contract, but again, and it's also not required. That's why it's underscored, but I just wanted to put it there that we have it. So are there any questions relating to this? Because now I will actually deploy on Remix and we'll actually interact with them.
Are there any questions about the code? Of course, it's a bit long contract with several functions, but yeah, if you have any questions or maybe any comments as well, like have you been developing the ERC20 token yourself or something like that? And if so, how it is different from this example? That kind of experience is also really helpful to contribute to the class.
Students, do you have any questions? Everyone went into mute.
No, ma'am, no questions as such.
Okay.
Yeah, then let's proceed, and then yeah, maybe you can put in the chat if you have any questions. Yeah.
Yes, and before we move on, I will just I will share this link to it. There's something called OpenZeppelin that make
Maybe
token
increase
deployment.
the font a bit.
Yes.
Siddharth.
Okay. Is this better? Hopefully, yes.
Yeah. It's
Okay. So it's something called OpenZeppelin. It's widely used. So whenever someone wants to create new tokens, they use their ERC20 token template. And again, this is an abstract contract, so they just have to use it and they can implement it. But the nice thing about it is does the same things, right? We have balances, we have allowances, total supply, name and symbol. So it does the same things. But the nice thing about it is if you look at transfer, let's just take a quick look at transfer. One of the simple transfers we look. Let's see if we can find where it is. Yeah. So if we look at it, what they've done is they've done a lot of checking onto simple issues that might come up. So in my contract, for example, if something goes wrong, it just errors out. This is something we'll see. But here they actually tell you what's wrong. So let's say if we're trying to transfer to the 0 address, right? It would actually say maybe it's an invalid receiver, right? And that's what it's doing. So I would highly suggest that, and then it updates. So update is like a basic method. And here again, all it does is it checks it, and then it does safe math as well. So when it's trying to reduce the number, and then it just does it well. So it actually does a lot of other stuff. So if you have the time or you're interested, I would highly suggest you to go through this. It's obviously a bit more complicated, but it's also much more stable and secure, which was also what Professor Rago was talking about before when he said that compared to my contract, even though it is secure to an extent, this is a lot more secure and has better error handling. I think that's what you were referring to, right?
Yeah. And also you can put the link in the slides so they can take a look at it.
Okay, I will do that. So now I think we can go to the demo. Well, again, I'm going to use Remix to do it. I think we already have the code here, but I will just take our code because we make some small changes and paste it here. Okay. Yes, now I will, this is something we've already seen before, so I'm going to go quickly and without really explaining, but we're basically just deploying the smart contract first. And we're going to work with it. And then we're going to deploy. Wait. Yeah, okay. Yeah, I was doing the wrong thing. I was actually deploying the interface, which we can't. But yes, so now let's look at it. So before we deploy, we have a constructor here, right? And what does the constructor say? We have to give the total number of tokens there are. So I'm going to say 100, and then I'm going to deploy. Okay. No, I understand what happened. It's because we have to remember to use a different compiler. So let me just do the process again. And then we deploy. And yes. No, that's the wrong one again. 1 second. And then let's say 100. We're going to deploy, and it should work. Okay. And let's just, as always, just check on Ganesh to see what has happened. Well, we've created the contract. Now, I'm just going to take a note of where the contract is. And it's also important to note who the sender is. And I'll tell you why in just a second. So let's just take a note of those two things. Yes.
By the way,
I would say-
during he is noting down, Sublime Text is a really good editor. I don't know whether you people are using or not, but we can really suggest it. It's like a Notepad++. You can do a lot of wonderful things. Even you can write a compiler or interpreter for your own language and things like that. But it works really, really good as a text editor, and it can load files even for 5 to 6 gigabytes of huge files in a simple editor. So this is one of the very good editors recommended, and it's free. It's open source and it's free.
Yeah. Yes. So yeah, I will continue. So we have the contract address here, and I'm also going to call the account that actually deployed it. So let's remember one thing: when I was deploying it, you had to have an account here, right? You had to choose an account because every smart contract has to be deployed through an existing address, right? Or an address. So in this case, this is the person who deployed it, and let's call him Bob. So we'll start with that. So all I did was just take what this address was and then set that he's Bob. Just do that again. Yes, and he's a contract deployer. Now, if you remember, when we look at this one, I said I'm going to mint all the supply, so all the tokens, to the person who's the message sender. So essentially the person who's created this contract, which is Bob. So now Bob should have the total supply, right? Just keep that in mind.
So that maybe you can increase the size, the
Yes.
font size a bit. So
I'll do
the
that.
contract. Yeah.
Is it better? I think it's
Yeah,
I
it's
can
better,
increase
yeah.
the size of this one, but yeah.
Yeah.
See, okay, this. So if we look here, should I try to increase this one? Yeah, okay, no, it's working. Yeah. So let's look here. So now we have the contract deployed at an address, right? And this is the same address that we've noted down here. That's the contract address. So interestingly, how many functions or variables does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's implementing all the functionality that is required, right? Of the ERC20 standard. Now let's do the first thing. So first is, my prediction is, or the way we wrote the code is, when constructor is called, and again, constructor is only called once, when the contract is created, it actually assigns all the tokens to the message sender. Now, if you remember what the function balance off is, let's see what it says. It says it requires an address. So because the ERC20 tokens, it's just a ledger, we should be able to say what is balance of an address, and we'll be able to see how many tokens it has. So let's do that. So what I'm going to do is I'm going to ask for how many tokens Bob has, who is the contract deployer, and he should have 100 tokens. I'm going to call it, and then if you can see the little value here, it's 100, which means Bob has 100. As you can see it here as well, right? So Bob has 100, and now for the sake of continuing the example, I'm going to choose another address, and I'm going to call her Jane. Okay, and now I'm going back. Actually, we can just leave it with the, yeah. I'm just going to note it down in Sublime Text. So now we have Jane, who is the second account that we had here. So now let's look at what Jane's balance should be. Like, how many tokens should Jane have at this point? Well, the answer is none, right? Because the answer is 0. They shouldn't have any tokens because we just created the contract and all the tokens belong to Bob. And Bob hadn't decided to transfer any. So let's do that. Let's look at balance of, and we're going to ask for Jane. Again, you can just double check that this is the same contract. It is the same contract. The last 4 variables are 3D, D5. So we're going to call it, and then the value changes to 0. And you can see it here as well. I will, can you see this value, or is it too small?
I think it's too small, but yeah.
Okay. Is this a bit better?
Yeah, it's better.
Okay.
Yeah, it's better.
Okay, because we can also always look here, but it's a bit small there as well. But okay. So yes, so what we've seen is that Jane has no tokens, right? Are you happy with that? I think we've shown that. So let's just write here. So in the start, Bob has 100 tokens. and Jane has just 0 tokens. Let's just note that down. And what I want to do now is I want to give Jane some tokens, right? So I want to use the transfer function. So to use the transfer function, what do I need to do? Well, first I need to select who the person who is calling this transfer function is. And the only person who has any coins is Bob. So we're going to choose him to call this function. Again, it's very important because when we click transfer function, it's going to look for who the message sender is. And the message sender is this address, who in our case is Bob. So now I will transfer from Bob to Jane. Let's say we transfer 10. So let's do that. So we're going to look at the transfer function. It requires the recipient. In our case, the recipient is Jane. Let's do that. And remember that when we do balance of Jane, we should get 0. And we did, but I will do it again. So this is Jane's address. And I said, what is the balance? In the ledger, how many tokens does she have? She has 0. It doesn't change. And if you look here, it's the same thing, 0 tokens. So now what I'm going to do is call the transfer function. So I'm going to put Jane's address here. And I already know that, and I'm going to say we're going to transfer 10, right? And who are we transferring it from? We're transferring it from Bob because he has all the tokens. So let's click transact. And let's make sure it went through, and it's a green signal, it went through. Now let's actually look at the event because we're generating an event. So what does the event say? This is the function that was called. And then it says decode output. If we come all the way here, it's not the nicest thing to see, but it says there's an event transfer. And it went from this address to this address. Who is this? This is Bob. Let's put it right here so we can see. This is Bob, right? Bob, and it's sent to Jane, and we transferred 10. So now our expectation is his total tokens should go to 90, and she should go to 10. Now, is there a way of checking it? Yes, we can. We just need to call the balance of function again. So let's first, I'm going to put these in brackets to say that it was the previous state, and let's see. So now when I call balance of for Bob, what should I get? I should get 90. Well, let's do that. Balance of, I put Bob, call, and it says 90. And that's exactly what we needed, right? Output is 90. So that's good. But now we need to also check whether Jane got the 10. So let's do that. So let's just note down that Bob's new balance is 90, and we'll check Jane's balance, or how many tokens she has. She's got 10. She's got 10, which means, what does that mean? That means that 10 tokens have been transferred from Bob to Jane. But now my question is, if we look at the code, what has actually happened? Or it's not actually a question. What has happened? Nothing has actually changed except the fact that the dictionary has adjusted the values, and that's it. So the concept of ownership of tokens is entirely dictated by how much amount of tokens is given in the balance of data structure, which is the dictionary, and that's it. So that's a bit important to understand as well. Now let's go to some more of the more complicated ones. So let's do the approve next. So what we're saying is we're gonna have to go back, and now let's choose, now let's just write that she has 10. Now let's choose a completely different address to be the person who can approve transfers from Bob to Jane, right? Or actually, we'll choose another person who receives from Bob. Let's do that. Let's say Jane, let's see. I'm just gonna choose an address first. So in this list, I'll choose the last address, and then we're just gonna copy it to clipboard, and we're gonna say, this is Ankit. Ankit is now this address, and his tokens will be 0, but let's very quickly double check. And the way we check how many tokens he has is simply by asking balance of. And that is his address because it ends in 90D. Yes. Call, it's 0. And we get a 0, which is our expected output. Oh, no, that's not the one. This one. 0, which is our expected output because he doesn't have any tokens. Now, what I want to do now is we're going to use Ankit as an intermediary. So I'm just going to write that. Which means that Bob will now give Ankit permission to transfer 20 tokens to whomever he wants, right? So what we're trying to do is, what we want is Bob is going to call approve Ankit for 20, right? But let's just do that approve. And then what we're going to do is we're going to say allowance, because if you remember, allowance tells you how many tokens has one address approved the other address to spend, right? It gives you how much amount has been delegated. So we're going to do that as well. We're going to look for how much has Bob allowed Ankit to use. So let's do that. First, let's approve Ankit for 20. So how do we do that? Well, the thing is, the approve, if we look at the approve function, the message sender has to be Bob, right? If Bob wants to approve, it has to be Bob. So we have to go back to this address. Why? Because that is Bob, 0FD. And now Bob will now call the approve function, which requires an address. So we need to give Ankit's address. Let's give Ankit's address. And let's say 20. We're going to transact. And it worked, right? So now let's check, because this is Ankit's address, let's check how many coins he has. How many tokens should he have now? Still 0, because we've only approved him 0, and we get 0 as well. And that's okay. But now we can actually look at how much allowance he's got, right? What is that? What am I doing here? Let's actually write down. So this is, we've just confirmed that Ankit still has 0 tokens. Now I've done this part. Now I want to see the allowance Bob has given Ankit. So let's do that. Let's see how that works. And again, the important thing with allowance, let's look at the code. One second. I'm just gonna reduce the size just to find it. And yeah, approve. Yes, I was looking for approve. So the important thing is we will look at approve. What was I wanted to look at allowance. Yes. So allowance is, yes, allowance is right here, right? Again, an important thing to notice is that we haven't created a function specifically for allowance, but it's been created here. Why is that? That is because in Solidity, as soon as you create these data structures, automatic getter functions are generated. So when we said balance off, it automatically generated a function for us, which took, if we look at balance off, it took an address and it gives you the value in that dictionary. So that's what it is.
Moreover, this is a public variable, right? So that's why it created a get and set methods automatically.
Yes, exactly. So it's done it. So now what I want to do is look for allowance. So here we have 2 addresses. Allowance is Bob. So first we need to see how much allowance Bob has given Ankit. So let's say Bob, and then we look for Ankit, who is here. Ankit here. We call and we get 20. And that is what we expected as well, right? Because, why? Because that's how much has been approved for use by Ankit. And we got 20 here. So now what we're going to do is, now we know that Ankit has been approved. What I'm going to do is I'm going to send 20 from Bob to Jane. And the important thing is through Ankit. So Ankit is the one calling, right? Before I do it, let's just quickly look at the transfer from function code, because that's what we're going to use. And this will show you how we are using it. So the transfer from, if we just do a basic search, it has a message.sender. So that's very important. So it means that the person who's calling this function is important. And now, because what did we say before? That Ankit is the one who has been delegated this 20 tokens, and he's the one transferring them. It has to be Ankit who has to call this. So let's do that. Let's first go here and change to Ankit, which is the last one. Let's just double check. 8F1, okay. And then we say transfer from, and let's see what that function looks like. Transfer from, yes, it has the sender. Who do we want to send the tokens from? We want to send the tokens from Bob. And also remember, Ankit has only 0 tokens, so it can't be him. So we send it from Bob, and we want to send it to Jane. Basically, what we did before with the normal transfer, except we're using transfer from and using Ankit as an intermediary. So we have a sender who's Bob, and we have a recipient who is Jane. And we're going to say 20. And now I'm going to transact. And before I do, this is how the situation is. So I'm just going to put this in brackets as well. This is how the situation is. And what do we expect to see? Well, if we're transferring money from tokens from Bob to Jane, 20 of them, then Bob's total amount of tokens should decrease to 70, and Jane's should increase to 30. So that's the test. 70 question mark, and then 30 question mark. Let's see what happens. So we said transact, and luckily it went through. Let's look at the logs, and as expected, it has a transfer event, which is saying from 0xFD03, which is Bob, to Jane. Again, there is no mention of Ankit, right? Who is Ankit in this situation? Ankit is a message sender, and that's it, right? So now let's do our test. Using balance of, the first thing we're going to do is see how much Bob has left. If what we did is correct, he should have 70. So let's do that. Balance of, and you can see it's 70 here. We can also see it's 70 here. So that first test worked. I'm going to remove the question mark. And let's look at Jane. How much does Jane have now? Balance of 30. Again, 30. So that means it's worked. So what have we done here? We've transferred coins from Bob to Jane through Ankit. And the way we did that is by using approve. We don't need allowance. By using approve and transfer from. Right? So this is what we did. And that's it. So this way, Ankit is intermediary. Yes. And so far, are there any questions now? Because I've covered most of what I wanted to cover for just the ERC20 token. Maybe before I take questions. Yeah, go ahead.
Yeah, go ahead.
Why do you need the approve function again? What is the use of it because I believe without the approve function, I can still send and receive.
Yes, you're right. So without the approve function, Bob can send to Jane by just using the transfer function. But the approve function allows another intermediary to do it. Now, why is this useful is something we'll actually see later in another example I have, but it actually allows us to create more autonomous smart contracts.
Okay. Yeah.
For now, that's the only answer I can give. But basically, it's very powerful in that it allows an intermediary to transfer funds.
So does it mean like it's giving a power of attorney to someone else?
Yes, exactly.
Yes,
that's what
it is giving power delegation to someone else. And again, imagine, let's say that there is a pretty big the token. Huge tokens managed by big company or something like that, then it cannot be handled by one contract or one address or one person, right? So then you need to have the some kind of intermediaries or some kind of the middle company, or you can say, who manages these kinds of things, similar to what happens in the IPO calls, where you have the securities companies who are helping the companies to launch IPOs, right? So that could be one of the scenarios where it will be useful. But it's a very powerful functionality which can be used in many ways.
Yeah. Are there any other questions? There's one in, oh no, nothing in chat.
Yeah.
No, so should I continue?
Yeah, go ahead.
Yeah. And also in total supply, we have 100. I just wanted to show that here. Yeah, 100. And that's going to remain stable unless we mint more coins or burn some more. But we haven't created more functionality for that. So the total supply of coins will always be 100. It will just go between people. Yeah. Okay, now I will go back to the slides. Can you see my slides?
Yeah.
Okay. So Yeah, so the next question is now actually, we've seen a lot of the implementation, we've seen how they work and what the standards were, but now is the question of like, why make these tokens other than the fact that they have some value? Like, why did they have some value? Well, if we ask those questions, the first one is, it provides a rich set of possibilities, right? It actually allows us to do a lot of things beyond just use Ether. And this rich set of possibilities is very true for people who want to do projects on the Ethereum blockchain. Because whenever they do projects on the blockchain, if you can have your own token, then you can kind of control the success of your, not that you can control the success of your project, but you can value the success of your project. So in general, what happens is, if I say I create a project of money lending on Ethereum, now, of course, I can always take a small cut of the Ether that's moving, but if I actually just have some tokens that I've created, and if I have it so that the more people use it, the more the price goes up, then I can also become, I can get my money through it, right? It's not just about getting rich, but it's about being compensated for that. And those things are actually there. And it's not only about this, but for example, if we take some other examples, sometimes it also is useful as a stable coin, right? So the Ethereum's price by definition will fluctuate, right? Based on demand and supply will fluctuate. But using tokens, you can create stable coins, and that have actually been done by some projects. What is a stable coin? It is a coin whose value does not increase or decrease above a set value, close to. So MakerDAO produces a stable coin called DAI, and that is pegged to the US dollar. So its price is always close to $1. It fluctuates a tiny bit, but overall it fluctuates very little to the point where it's a stable coin. And there are some other projects like that. So that's one way in which you can actually provide value. So in this project, they used tokens as a way to create a coin that has a stable value. And the other thing is you can actually create tokens, what are called governance tokens. So in a lot of places, they've created voting based on how many tokens you have. So let's say there's a project, again, MakerDAO can be an example, where they have to make certain decisions and they wanted to decentralize these decisions. And the way they did that is they created another token on top of the DAI, which was a stable coin, which allowed anyone who held that token to vote. What kind of voting? It's something, it can be wide and varied. It depends on the smart contract, but essentially what they do is the account will then cast votes based on how many tokens it has. So that's one way of viewing it. And lastly, if we just think of the ecosystem perspective, it actually gives you a greater transparency if everyone is following the same standard, right? So if someone says, hey, I've created a new token, you should buy it, then you actually know what to look out for. You still have to do your due diligence, but this provides you a way to actually verify, provides you a way of verifying and actually providing greater transparency on what functionality you can expect at a minimum level. And finally, it also allows for easier integration of tokens. So last class we saw MetaMask, right? And we saw that if you have new tokens, MetaMask will immediately tell you how much balance you have. And how does that do that? All it does is call the token smart contract saying balance of, and it will get it. And given that all the tokens are following these standards, again, there are different token standards as well, of course, but if most are following this ERC20 token standard, that means that MetaMask doesn't need to write custom code to interact with each token. It can just use the rich API set defined by the standard to actually use it. So with that, what happens is that there's just greater adaptability within the ecosystem. And it actually is a kind of a sign of maturity for the ecosystem to have these standards that people follow and standards in terms of security as well. Now, I think we can move to what are called the decentralized autonomous organizations, or DAOs. So far we've seen a simple smart contract that provides tokens, right? The ERC20 token. Now, oftentimes they're used in complicated projects. And by complicated, I mean to define any projects that utilize more smart contracts to achieve a function that is quite complex, right? It's a circular definition, but I think it works. And essentially DAOs, the process of it, or the aim of DAOs, is, if we go through each letter of what it stands for, first is they aim to be decentralized, which means they don't want a single person to have all the power, right? So in our ERC token situation, a single person did have all the power. Bob was the only one who had control over all the supply. So that's not necessarily decentralized. And then the second part is they wanted things to be autonomous. What does that mean? That they want these collection of smart contracts to work together independently of other people's governance inputs, or limiting it as much as possible, right? And they want to be organizations. Organizations, I think we can just understand it in terms of how there are a lot of organizations in the world. In Ethereum, a lot of the organizations are built around decentralized finance. So the organizations exist in the form of lending, in the form of providing stable coins, when we saw MakerDAO and things like that. And the whole point is that the whole ecosystem of Ethereum comes from the idea that you shouldn't have trust, or you want to build a system that is trustless. And the goal of these organizations is to provide the kind of important and necessary functions that organizations normally do outside, like lending, like borrowing. They want to do that within Ethereum and in a trustless system. And that's what they come to call decentralized autonomous organizations. And oftentimes, not always, but oftentimes, there is some governance that has to do with these things. So it might sound a bit like a contradiction to say that you want a complete decentralized autonomous organization, but then there will still be some kind of governance by users. Well, the thing is, it's just a fact that the more complicated organizations get, like if we take money lending, for example, there will have to be some governance involved. So what a lot of these people have done is they use tokens, ERC20 tokens, to allow for governance. So where they can vote on certain things. So once the smart contracts have been put in place, they allow for a few parameters to be controlled or modified by people who hold the governance token, just to ensure that the project is surviving. So that brings me to my last point, that it's you who needs to decide what qualifies as a DAO. Because
Sorry, could you just repeat the last point? I couldn't hear you.
The last point with the governance?
Yeah.
Yeah. So in this situation, right, a lot of the times organizations in Ethereum, when they grow, they become quite complicated. So then they actually allow for certain parameters in the project. So let's take money lending, for example. We have, whenever you lend money, you expect some interest to be paid, right? So that interest rate could actually be set by some people who own the governance tokens, right? So let's say you can borrow some money in Ethereum you say you can borrow 2 Ether or something. And then when you pay back, you have to pay back some interest. That interest variable in the smart contracts can be made so that there is actually some governance on it, so that there will be some voting involved to either increase the interest rate or decrease it, right? Why? Well, it could entirely be based on demand. Let's say the project is being flooded by people wanting to borrow money. What you have to then do is you have to increase the interest rates so that it's kind of like the demand and supply thing. To reduce the demand, you have to increase the cost of the service. In our example, it would be interest rates. So those things can actually be done through governance. Again, I'm speaking at a very high level because unfortunately these things, what are the parameters that can be changed and stuff, is entirely dependent not only on the project, but how the smart contracts are themselves created. So that is just something that, we should keep in mind. So now, back to my point about what you need to do, like it's up to you to decide what qualifies. I think this term itself can be a bit contradictory because if you have a proper organization, it honestly can't always function autonomously. And if it does actually function autonomously, it probably is not decentralized, right? That there is someone who's overseeing it. So at the end of the day, a lot of projects claim to be a DAO, claim to be following this, but it's on you to actually investigate the project and figure out whether they're actually a DAO or to what extent, because this is quite an abstract concept, and you have to be the one to be okay with how much decentralization there is, or is there a hierarchy, in which case it's not exactly decentralized. If there is a lot of user input, maybe through governance, then it's probably not all autonomous, or maybe it's just not a big organization, and that's okay as well. But I just want to make the point that given that there was a lot of scams and stuff in the blockchain ecosystem, it's just important to not go by what people call them, but actually just analyze it for themselves. Yeah. Are there any questions?
Yeah, I think we are coming to end. Maybe you can.
Yes.
Yeah. Is there a
Would
question?
it be possible to take over a DAO? You know, something like a 51% attack when I just take on more governance tokens, or if I have the power to pitch in more, contribute more to the project and have more stake in the project, then it doesn't really, the efficacy of a DAO fails.
Yes.
I can answer that.
Yeah. Okay.
So definitely, it depends upon the decentralized the currencies and the decentralized applications, right? So even for let's take an example of Bitcoin. You can say that Bitcoin is now grown out of that risk. So it's not easy to create a 51% attack on Bitcoin, because you need to have 51% of all the Bitcoins, or at least that much worth of the computing power you need to have now, which is really, really difficult to get. But on the other hand, imagine that there are several currencies like the Bitcoin, they started, but soon they got, they are susceptible to these 51% attacks because they were in the small ecosystem kind of thing. And it was easy to produce these kinds of attacks. So it really depends upon what is the company, what are the rules, and what kind of opportunities it has, and things like that. So even for Ethereum was susceptible to attacks previously. Now they were filled all the holes and bugs in the code and things like that. Now they became more stable in a sense. Now it is very difficult to emulate attacks on the established ecosystems and things like that. So any DAO, probably they have to go through this phase, but it depends when this attack is generated. If it is in the inception of the these application, decentralized applications, then there might be chance to take over or something like that.
Yeah. Yes.
But
So
with a smart contract, would it be possible to cap the amount of tokens it can hold per address?
Yes, sir, exactly. That was my doubt. Like, can we employ a system where it can figure out that some accounts are being held by only a single entity, and then it's capping?
Yeah, so that's a good question. Unfortunately, you can't. Or do you want to go first? I think you can go first.
Yeah. So again, you can do the coding so that only one contract get maximum 30% of the tokens, right? But on the other hand, people can do all sorts of things. So for example, let's say that I create 3 accounts, because what we have at the end of the day at the contract is bunch of addresses. I can create 3 addresses with different names or different things, and then I can get 3 into 30% stake. Then it will defeat it, right? So it's you can put, but again, how far the people can subvert these restrictions and things like that.
Yes, I completely agree. I was agreeing with you completely. So the thing is, you can always put restrictions, but they won't be useful simply because you're operating in a trustless environment, in which case you're actually giving almost every address equal weightage. So you can always record a bad actor and say that, okay, we're not going to take votes from this person. Well, all that person has to do, because these are fungible tokens, is create a new account and transfer them. Then it's on you to then add another account. But how many accounts are you going to block? Because there's no cost to creating a new account necessarily. Like maybe there's a small one, but a bad actor who has the resources will always be able to find a way out of just being blocked, right? So it won't be possible. Yeah.
So that's true. And maybe let me complement also this using the example, right? So it many times it is not the code which can protect these type of attacks and things like that. It is the community which can protect. Take,
Yeah.
for example, the Ethereum. Ethereum was suffered with this DAO attack where we discussed in the classroom that it was somebody has stolen so much money and more than $100 million or something like that. And then how did it survive the attack? Because the community, majority of the community, they still believe in these decentralized norms and things like that. They want to do things properly. So that's why they forked they made a hard fork and survive from the attack and things like that. So if we ask you cannot code them, hard code them in the form of the smart contracts, but it is always the ecosystem and the community around that one who are protecting that. In my opinion, that is what it is protecting.
Yeah. And just to finally add, I know we're running out of time. So that is the questions that have been brought up are precisely the arguments that were put forth to not have governance tokens. It's not only about necessarily a bad actor. It's also about if a one entity gets more than 50%, right, then he becomes the owner. What is the whole point of the blockchain, or the point of decentralization is that power is spread across and that there's no one or two main powers leading it, right? So it actually defeats the entire purpose as well. But the more you look at these projects, it becomes very hard to create a very complicated project without resorting to some kind of governance. And that's the crux of the problem, I would say as well. It's that yeah, I will just leave it with that. It is a
I
problem.
think it's just one of those things you just have to live with if you want to use
Yes.
it now or something.
Yeah.
That's exactly
And
what it
maybe-
is.
live with it, and then and then also look for these kinds of challenges, right? Maybe the community should be aware of these things, and then whenever some bad behavior happens, then the community could attack them, and so
Yes.
these things are possible.
Yeah, and last point I will add, I know we're running out of time. Last point is that usually these projects like MakerDAO, they have a foundation. So the people who built it, they usually try to control a certain amount of tokens. Again, they don't want to control more than 50% because it goes against the idea of decentralization, right? Sometimes they do. So MakerDAO, the last time I checked, controlled 20% of the total coin supply, right? It might not seem like a lot. And of course, some other person can come and buy up the 80. But because of how popular MakerDAO is, for a person to buy up 80, he has to spend more than like $1 billion or something like that. And automatically that also makes it very inefficient for a bad actor to take over. So it also depends on the popularity of the project, weirdly. So if the foundation actually does a good job of getting more users while they're maintaining the hold of, let's say, 80%, and then once they're at a threshold, they slowly give up the coins and stuff like that in a very careful way with community action and do it in a good way, then you can actually ensure proper governance.
Yeah. And maybe let me comment on that a bit more, and then Siddharth, you need to show the code again, right? Or should we push it to the next week? About the, have you shown two contracts or?
No, I haven't shown the other one. No.
Okay. Yeah. We are, I think, running out of time. Should we do it for the next class? Yeah. Maybe we can copy the. So let me comment on this one, and then we can close down. And so even if you look into the Bitcoin, remember how the Bitcoin, one of the main fundamental design principles for the Bitcoin is decentralization. And people thought that you should be able to mine the Bitcoin cryptocurrency on the laptop. So that's why there is a 32-bit hash function is used for mining and other kinds of things. But look into now how the mining has been centralized, right? So if you look into this evolution, even though it started with some good fundamentals and other kinds of things, but the mining is completely centralized by the few mining companies. Now, nobody can mine unless you have a few $100 billion to invest and go for mining and things like that. So these kind of practices, even though you cannot predict how they will evolve, even if you don't want to do it, or you started with a very good fundamental principles and good principles, sometimes they can go in the other direction. So that's what happening in the Bitcoin. So, and then what we do is we still have one more contract, right? The vendor contract and things like that. So we will copy the contracts into the code folder, go through them, and there is a lot of code, right? Even ERC20 token has a lot of functions and things like that. Maybe go through them and execute it yourself in the Remix and Ganache and try to see them. And then we will go through the second contract, the vendor contract, on next Friday. Because on Monday we are going to have the class, the presentations, and next Thursday the class is moved to Friday because I have a workshop on that day. So on next Friday. Any other
Okay,
questions or
Professor.
comments?
Yeah. Yes, students, do you have any questions?
No, ma'am.
Yeah. Okay, I think they have
How
sorted
many
out
of you?
the
How
lesson.
many of you have developed ERC20 token? I know some of you are already doing a blockchain programming, right? So, did anyone develop? Did anyone work with ERC20 tokens or some kind of smart contract?
Yes, sir.
Okay. Yeah. So yeah. That's good to know. And is it completely different what we have seen here, or is it in the more or less in the similar lines? I just want to know your
No,
experience
sir,
and the
we have also used Open Zeppelin only to take the contracts.
okay.
So it was same.
It's good to know. Yeah.
It was a bit more clear since you were explaining everything and we had to figure it out on our own, but the source was same, yeah.
Okay. That's good. So yeah, then we can call it a day if you don't have any questions or comments, and then we will please go through them. And many of you have probably didn't have a lot of experience, but try these things and run these things, and maybe do the testing, and then only you will come to know about a lot of the underlying things. Yeah. Okay, then good night. And yeah, let's call it today. Thank you.
Yeah,
Bye.
good night, both of you. Yeah.
Good night.
Good night.